In your notebook, write today's date, 9.1, add and subtract polynomials. Copy these notes down. Monomial. A monomial can be a number, can be a variable, can be a product of a number and variables, can be having only a whole number exponents. So a monomial may not have a variable in the denominator, may not have a variable exponent, and cannot be a sum of terms. So examples of monomial and non-monomial follows here. So monomial in this case just has a number, just the variable, so they are fine. The product of a number and a variable is fine. The product of number variables is fine. And the number may be negative, but the exponent has to be positive. And the exponent can either start from a 0, 1, 2, and so on. The exponent cannot be a negative exponent. So some of the non-examples of monomial will be, in this case it is not a monomial because the variable is on the denominator. In this case, it is not a monomial because the exponent is negative. This is not a monomial because you have a variable for an exponent. And this is not a monomial because you have a sum of terms. Now copy these terms, this vocabulary as well. And this will make sense as we delve into the particular solving of questions. Polynomial can be just a single monomial or can be a sum of monomials. The degree of a polynomial will be the largest degree. Leading coefficient, to find that, you need to arrange the polynomial from greatest to least, and then you find the leading coefficient. And binomial, bi means 2, so the sum of two monomials becomes a binomial. Trinomial is tri means 3, so the sum of 3 terms. Now, copy question number 6. They are asking you to write the polynomial so that the exponents decrease from left to right. Then they are asking you to identify the degree and the leading coefficient. So those are the two information that they are asking you to find. So number 1, for question number 6, you are looking at the exponents. The exponent is 3 and this exponent is a 1. So this is in order. The exponent has to be in decreasing. They have to go from highest to least. So once you find that they are in order, then the degree in this case becomes the highest exponent. So the highest exponent in this case is 3. And the leading coefficient will be 5. I'm getting this information from here. The degree will be the highest exponent. You may want to write a little tip to yourself. The leading coefficient, L stands for leading, C stands for coefficient. The leading coefficient will be the number that is tagging along with the variable. So 3 and 5. Now let's focus on question number 7. Copy this term. Number 1 you need to identify is this is not in order, so you need to rearrange. When I'm talking about rearrange, I'm talking about getting the highest exponent first. So I'm getting 3z 4. Then I'm looking at 2z to the power of 3 minus z squared plus 5z. When you're rearranging, you need to tag along with the variables along with their signs. So once you get them in order from greatest to least, now you're finding the degree. The degree will be the highest exponent. Write a little tip to yourself. The highest exponent in this case is 4. So my degree is 4. My leading coefficient in this case becomes a 3. And if I highlight and show you, my leading coefficient is 3. My degree is the highest exponent, which in this case is 4. Copy down question number 8 and ask the question, is this in order or do you need to arrange it in order? The answer is you need to arrange it in order. If you look at it, it's going from 2, 4, 6. It has to be the other way around, biggest to smallest. So I'm rearranging to get negative h6 plus 2h4. 4 comes next. So now if you look at the exponent, I have 6, 4, 2, and now they are in order. Once I got them in order, so now the degree in this case will be the highest exponent. The highest exponent is 6. And the leading coefficient in this case becomes my negative. There is no number, so you just attach a 1, so it becomes negative 1. If I were to highlight and show you, this is my degree, the highest exponent, and This is my leading coefficient, which is -1. Copy question number 9. This is an EOC kind of a question. So they're asking you to find the degree. So the first step is you get minus 4x cubed plus 6x to the power of 4 minus 1. Common mistake students make will be they do not rearrange. So number 1, you have to rearrange if it is not in order. So let's rearrange them to get 6x to the power of 4. Rearranging means you get the exponents of the highest first. Then you get minus 4x cubed minus 1. This doesn't have any exponents. It doesn't have any variables, so it comes last. So now the degree in this case becomes the highest exponent. The highest exponent is 4. The highest exponent is 4, and that is my degree. So the answer in this case is C. Copy this question. This is also an EOC kind of a question. They're asking which expression is not a monomial. A monomial can either be a single term, can either be a product of terms, can have positive exponents, cannot have negative exponents, cannot have an exponent, cannot have a variable on the denominator. So go back and refer to the first graphic organizer which I gave you. So A is, yes, it is a polynomial. It is a monomial because you have minus 5 multiplying x to the power of 2. The exponent is positive. B is a monomial because you're just multiplying and the exponent is positive. C is a monomial because you're just multiplying, it's a product. 3 multiplies a variable, it's allowed. D is not a monomial because you have a negative exponent. So the variable has a negative exponent, which is not allowed. So the question is asking which is not a monomial, and the answer is D is not a monomial. Question number 22. Let's arrange it, simplify it, and then find the degree. So the first one is 3x squared minus 8. Let's rewrite it without the parentheses. The second one, if I need to open the parentheses, I need to apply my distributive property. So distributive property I need to apply. So there's no number. I'm going to stick a 1. So I'm going to apply my distributive property for each one of them. So negative 1 multiplies 4x cubed to give you a negative 4x cubed. Negative 1 multiplies positive to give you negative x squared. Negative 1 multiplies negative 15x to give you positive 15x. Negative 1 multiplies positive 1 to give you negative 1. So now once you get this one, now you're looking to see if there are any terms that you can combine. So I'm looking at x squared and x squared. I can combine both the x squareds. So pause the video, go and grab a couple of color pencils, highlighters, or crayons, anything that you might have. So x squared and x squared combines. So you get 3x squared minus 1x squared. So 3 combines with negative 1 to give you 2x squared. Now I'm looking to say negative 8, which doesn't have any variable. I'm combining it with negative 1. Negative 8 and negative 1 combines to give you negative 9. Now this, there is nothing else to combine with. So I'm just going to bring it down. And positive 15x, there is nothing else to combine. I'm just going to bring it down. Now the question was asking you to find the degree. Degree meaning the highest exponent. So let's rearrange it. So rearranging it implies minus 4x to the power of 3 because the highest exponent is 3. And then comes plus 2x squared. If this doesn't have any sign, you consider that as positive. Attach a positive sign and bring it down. This goes next, plus 15x. And the last one is minus 9. So once you get this in order, now you can find the degree. The degree will be the highest exponent, and the highest exponent, if I highlight and show you, in this case will be 3. So the degree in this case is going to be 3. The leading coefficient in this case becomes negative 4. If I highlight, this will be my leading coefficient, and this is my degree, which is 3, which is my highest exponent. Now copy this question. Really a simple question. So you're going to open the parentheses. The first one I'm going to write it as 9p squared minus 6p to the power of 3 plus 3 minus 11p. And this one, if you apply the distributive property to open up the parentheses, so it's just going to be plus 7p to the power of 3 minus 3p to the power of 2 plus 4. So once you get this one, now all you need to do is combine the like terms. So p squared, you're looking for another one which has a p to the power of 2. So this is the only one that has a p to the power of 2. So those are the only two things you can combine. So 9 and negative 3 combines to give you 6. P squared, you just bring it down. So let's see if you can combine anything else. So I got p to the power of 3 and p to the power of 3. You're looking for like terms which has the same variable and the same exponent powers. So this will give you negative 6 and positive 7 combines to give you positive 1 p to the power of 3. The next one, positive 3 combines with the positive 4 to give you positive 7. Now this one there is nothing else to do, so I'm just going to bring it down. So once you are simplifying the expression, now you need to rearrange it. So let's rearrange to get 1 p to the power of 3, that is the highest exponent, plus 6 p to the power of 2, which is the second one, minus 11p, which is the third one, and positive 7, which doesn't have any variables or exponents. So once you rearrange it, now you're going to look for the degree. The degree in this case is 3. That is the highest exponent. And if they are asking you for the leading coefficient, the leading coefficient becomes a 1, because that is the number that is tagging along with the highest exponent.